So the issue before me is relatively simple compared to the complicated things that you've been hearing now. It's just a simple matter of the connection between mind and matter. Now, this is a foundational issue. It's right down at the bottom level of what our basic understanding of the basic laws of nature are. And I think most of you will understand the difference between mind and matter. When I'm speaking of mind or mind-like things, it has to do with your experiences, the actual things that you're experiencing now. And you see a certain visual scene, and it's the experience that we're talking about when we're talking about mind. Whereas when we're talking about matter, we are generally thinking in terms of tables and chairs and rocks that are out there, and they're built out of atoms and molecules. And most people don't think, at least intuitively, that your mind, your thoughts, are made out of molecules. They seem to be made out of something different. And now, the question here has to do with quantum mechanics. As most of you also probably know, before quantum mechanics, there was classical mechanics. And classical mechanics was the theory basically invented by Isaac Newton back in the 17th century. And even then, people were aware of this distinction between mind and matter, but Newton's theory said, no, he was going to build a theory just out of matter alone, leaving mind out of it. So this is classical mechanics. It's all supposed to be basically the idea we have these particles moving around. They have certain laws connecting how they act upon one another, and you're given what is called a physical description of nature. It's all about the motions of particles. Particles are located at certain places, they have velocities, and these all interact with each other in a way. And the laws that Newton invented were deterministic. That meant you're given the state of the universe at some early time, and then everything else is completely determined. So the fact that I'm sitting here on the stage here was already determined billions of years ago by the laws of physics, and although we think that we have some influence on it, that's just has got to be an illusion from this point of view. It's really all determined billions of years ago just by the laws of nature and these moving particles. So those ideas worked. The Newtonian ideas of a deterministic, physicalistic universe worked fine until about the beginning of the 20th century. And then all sorts of experiments began to reveal that they weren't working and seemed to be absolutely incompatible with that deterministic idea. And so the experiments started around 1900 and continued on for decades with more and more mounting evidence that said it's not working, classical mechanics is not working. And around 1925 and 26, a bunch of scientists, namely Heisenberg, Schrödinger, Dirac, Pauli, Born, those scientists finally worked out amongst themselves a new idea of the basic foundations of science. Now, science comes from the word skira, which means to know, and so they went back, as many philosophers were saying at that time, that the basic things that we should build our science on is what we know, namely our human experiences. So the shift was made from basing your fundamental theory on physical things, particles moving, to something else, namely our human experiences. Philosophers had been arguing, well, the only things we really know for sure, and there's all this confusion about how to make things work, that's what we really know are our experiences, and hence science should be built basically upon our experiences, our knowledge, which are in our minds. So mind became basically the foundation of quantum mechanics. It was based fundamentally on mind. And not only, and this is a key point, not only was mind entering as an observer somehow of the physical world, and closely connected with what was going on in your brain. But mind entered also by putting information into the system from the mental world into the physical. So mind became a player in the dynamics. And that is essentially the big essential difference between classical mechanics and quantum mechanics. In classical mechanics, mind is just not in the picture at all. You're not even allowed to mention it, and it's totally banned from the discussion. Whereas in quantum mechanics, mind enters not only as an observer, but as an actor. There are tons of quotes that you can quote from all the major founders of quantum mechanics, that the key new idea was that mind was entering not only as a passive observer, but also as something that enters into the determination of what's happening. Now, this actually is far more intuitive, in tune with our intuitive understanding of ourselves than classical mechanics. According to classical mechanics, we're just all robots. Why there should be any conscious experience at all is a big mystery. Why should there be the experience if it doesn't do anything? Everything is determined physically, and according to the classical idea, we're just robots that are playing out some pre-existing script. And so the key point of the evolution of quantum mechanics, as understood by the founders of quantum mechanics, was this idea that mind is entering into the determination. That allows you to be as you experience yourself, that you're experiencing yourself as having a role in how you behave. I want my arm to rise, and I do something mental, and up it goes. And so that is the key revolutionary change that was brought on by quantum mechanics. And given that, the answer is mind element needed to interpret quantum mechanics. The answer is definitely yes. I mean, that was the whole, the main point of the original idea of quantum mechanics. Now, that would be a simple answer, except later, past 50 years moreover, some other physicists have said, well, we don't really need mind. We can dream up some other theories that use the Schrödinger equation, which is the equation of motion of quantum mechanics, and get away without the mind. And so the question is, well, kind of what is quantum mechanics? Now, certainly, the original idea of the founders of quantum mechanics was absolutely mind is essential. And so the other question is, well, what is the status of all these other theories? There are dozens of theories out there that say basically we can find a way to use the Schrödinger equation in some other way of thinking about it that doesn't really involve bringing the mind into the determination. Now, of course, if that's true, it would revert us back to robots. I mean, that says mind has nothing to do with it. We're all just robotic, physical. So it's against your intuition. On the other hand, these scientists claim that they can get away without mind. As I say, there's probably at least 24 theories out there that make this claim, and they all disagree with each other. And so it's one indication that none of them are satisfactory. Even the people that want to leave mind out can't agree on how to do it, and the ideas are all over the map. Now, I believe, based on my own look at many of these other theories, that all of them are not rationally coherent. And there is a reason why I believe all of them fail. And how am I doing on time, by the way? Deepak?
Yes, sir. So I thought we'd have Stanley Klein come and comment on what you said. We're going to have a lot of sessions actually on quantum mechanics. We have.
Let me just say then, do you want me to say something quick?
Yes, sir.
Quickly, I'll say, I believe that none of the other theories work. And there's a basic reason, that is, if you just have the Schrodinger equation, it makes everything into a blur. The position of a particle is blurred out, and even the position of the macroscopic pointers get blurred out. And the way quantum mechanics has to solve this is from this equation that only generates smooth, continuous things, you have to generate questions that are asking a specific yes or no question about something. That's the way quantum mechanics works. And I'm convinced that there's no way that these other theories can do this without, I can go into the details, but that's the basic.
So we're going to hear about these other theories. We have other physicists. Werner's there. He's going to Erhard is going to speak about the other theories. I'd like Stanley Klein, who's from the same institution as Dr. Stapp.
Okay, I'll sit.
For those of you who are not familiar with this, for those of you who are not familiar with this territory, and correct me, Leonard, if I'm saying anything incorrect, quantum mechanics, the mathematics is Schrodinger's equation. Nobody argues about that. What they argue is the 10 different interpretations. And so what we're here to see is what are these different interpretations. And Stanley Klein is going to comment on Henry Stapp's presentation, and then we'll hear the other people as well.
Well, thank you so much. Quantum mechanics turns out to be something very complicated. So my goal in this is that quantum mechanics turns out to be very simple, and the message I'm going to be presenting is that it's a fantastic device for building bridges from spirituality to the rest of science and anything you can think about. So quantum mechanics is a very special theory. We have these two questions that Henry Stapp had, and they're in the title of this symposium. And so let me just begin by at least answering those questions. The first one is the mind needed to interpret quantum mechanics? And not only is mind needed to interpret quantum mechanics, but an observer is one of the two essential components of quantum mechanics. The type of mind that the observer has will be discussed. The second question is, do physically undetermined choices enter into the evolution of the physical universe? Not only do our physical undetermined choices impact our future evolution, and Henry Stapp is a leader in showing how mind can affect the volition, how human volition can be connected to quantum mechanics, but with a healthy spirituality a la Deepak. And so that future can be wonderful. So the future, for that wonderful future, we need to build sturdier bridges between science and spirituality for better caring of our world. This was the first edition that I turned in, and then when I read this booklet over here that everybody has, I replaced the word caring for, let me read it, the bridges between science and spirituality for a peaceful, just, sustainable, happier, and healthier world. So everybody should have this. Does everybody have this booklet? Or? Yeah, okay. So this is my message. So this is my introduction, and that's the purpose of my talk, is how quantum mechanics, a simple theory, can achieve Deepak's goals. I'm going to, and item number 2, that'll take the most of my talk, is trying to give a glimpse of quantum mechanics. How do we understand it? And then back to my theme of how it can build bridges between spirituality, science, and philosophy, and you name it. So this is how you can understand quantum mechanics. It's Feynman's multi-path view that everything is made of particles, and you have the initial particle coming in on the left, and then at the first observation, the experimenter sets it up, and then that particle can go in lots of different paths. And then another observation takes place, and then that particle, say it's the particle, say a photon or an electron, then that particle gets collapsed and it becomes, instead of being all spread out, it becomes where the observation consciousness, where it was seen by the observer. And then it spreads out again, and then the third observation takes place. Now, I've been saying that this is a particle, but each little line can either be a particle like a photon or an electron, or it could be a composite thing like deuterium, which is a nucleus. It's a proton and a neutron. So you can, and so each of the lines could be a deuterium particle. That's a proton and a neutron with all these quarks going back and forth and interacting. And so then we have each of these lines can be a deuterium thing. Or maybe it can be even something more complicated than deuterium. Maybe it could be a cat that's alive, or Schrödinger had it as being dead, but this is a sleeping cat. So we can have a cat that's a superposition of being alive or being sleeping. And so now, that is what now you know about quantum mechanics. So quantum mechanics is that there's observations, and then there is between the observations, all hell can break loose. And that's basically it. Feynman gave the rules. It turns out because it's two things, observations and the and the projection from one observation to the next, which is all the Schrödinger equation or Feynman's sum over all paths, this is a dualistic system. Dualities are ugly, but there's a solution. If you look in your book, you'll get the history having to do with the hippies, how the hippies say physics. It's in my biography. Why I got the California license plate of duality. And so if you see this, you'll know who it belongs to on my car. So the big issue is, who is the observer? Henry has an opinion. I'm a bridge builder. So let's now examine who is the observer. Well, the observer, and Henry, I think, would agree, the observer is you. You, the people, are the observers, and when you observe, you collapse the wave packet. Well, it could be, that's one point of view, and it's a true point of view. But there could be, instead of all of you being observers, it could be that I am the observer, and all of you are in my mind. That's legitimate. And then it can even be going a step further. Not just me, but my brain, and the front part of my brain is where volition, anyway, that's a special part of the brain. And so it could be my brain that's the observer. And this is relevant to spirituality because, and we heard those incredible talks about how meditation can affect how one's genome, how the RNA and the DNA. So, and this is the highly recommend. I was shocked, Deepak, when I saw that your book with Tansy, you had a section in there on the placebo. Sometimes the placebo, that word is a diminishing word, but it's actually that the mind can actually affect all sorts of systems. And in fact, there's a quote from the book, Self-Healing Through the Placebo Effect. This is a quote from Deepak and Tansy from Chopra. Depends upon freeing your mind from doubts without deceiving yourself. And quantum mechanics makes it legitimate to not deceive yourself because quantum mechanics can implement these things. Well, now I want to build bridges. So these can be bridges, and Deepak can't be beat in making these bridges to spirituality, from quantum mechanics to spirituality. I'm going to also want to make the bridge from to humanism or naturalism, to the more agnostic-y kinds of the skeptics of the audience. And my disclaimer is that I'm the membership chair, so I'm kind of advertising my the Institute on Religion in the Age of Science, which was created 60 years ago when the people at MIT and Harvard were panicking, 1954, nuclear warfare. So they created this group to deal with the horrendous possible futures, and now we have climate change, et cetera, that Deepak talks about. So let's go back. Now the first one was the cut, the Schrödinger, the von Neumann cut was put above, but maybe to include the naturalists, we can put the cut down a little lower. So maybe the cat can be the cut. Now there's a little dot. You see that little dot over the cat? Well, maybe the firefly can be the cut. We don't know where the cut can be placed. And the most extreme placement, maybe my iPhone can be the observer. We don't know that. There's a question mark. Who can be observers for this? And so this is a bridge-building exercise by the flexibility of the placement of the quantum cut. Everybody and their ideas are included. It is a humility exercise in the flexibility. That's why, again, my license plate duality can be very flexible and be inclusive to various different points of view. So now I'd like to just very quickly, I'm almost coming to the end, more bridge building in addition to this placement of the split as being the bridge builder, bringing people together. There's the thing that Deepak mentioned of the multiple interpretations. So going down the list, I don't think it's legible. It starts with Heisenberg and Bohm, de Broglie, and then von Neumann is advertised. And so all of the horizontal rows, the rows are different interpretations historically listed. The columns is what's exciting. Anybody can go to Google and just type in interpretations of quantum mechanics, and you'll get the Wikipedia site for that. And the columns are different ontologies, different philosophical aspects. And if you look down the observer role, that's 1, 2, 3, 4, 5, 6, 7, no, 6. You'll see that the von Neumann is causal, that the observer's role is causal, but there's these other interpretations that have different opinions about, and they're all giving the same data. So that's amazing. Here we're almost at the end. So in the middle is science. Science means just doing experiments and doing something that's replicable. And that you then make theories about what's underneath and how the world works. And then surrounding it, I put various types of spiritualities or religions, stuff like that. On the top is Deepak, Cosmic Mind. You'll find that in the three Huffington Post, the two of them over there, wrote in the last month, 3 Huffington Post articles on the same topic. Those 2 questions was the name of the Huffington Post. But then we have the most interesting ones are on the 2 top. The panentheism is the Cosmic Mind is kind of a Hindu of metaphysics, but panentheism recently has become what the Christian religions have modernized to be compatible with science. And the Vatican I advertise because they're a very big group. I put the Vatican rather than Catholic Church because those are the more science people, the Jesuits. And so they are totally science compatible for reproducible data. There's philosophy, and even we have Shermer here. The skeptics can fit in. There's branches of quantum mechanics that can please each of these kinds of philosophies. The one thing, this is my, I think, next to the last slide. This is the scheme of how science works. At the bottom is physics, then chemistry, biology. And the thickness of the arrows is just how much is known about that connection of levels. And we know almost nothing. Though we had those 2 presentations about an hour ago, was pretty impressive that there is the connection between neuroscience and psychology. Progress is being made, but let's wait another 50 years before any real progress. And then to connect to the next one is something called the hard problem, qualia, and so that there's even bigger mysteries. So this last slide I came across, this is my favorite book is the QED book by Richard Feynman. In between observations, it's very hard to tinker. Whitehead and process theology have tried tinkering at the bottom, putting in something in addition to quarks to make consciousness work. But it's very hard to tinker because right now, the quantum mechanics in predicting at least the magnetic moment of the electron is known to 12 decimal places. 1, 2, 3, 4, yeah, it's about 12 decimal places, which is an accuracy of the distance from the Earth to the Moon, and I calculated it to make sure that it was right, to an accuracy of the width of a hair as compared to the distance from the Earth to the Moon. So it's very hard to tinker with it. It looks like a very successful theory, and it's able to bridge all sorts of gaps and build all sorts of bridges, which is the theme of mine. And I'll just end next to last slide, that again, the emphasis for our group here of science and spirituality is that the neural correlates and the consciousness itself is part of quantum mechanics, has risen that to a very important one half of the duality. And I would surely strongly, in the power of the mental effort, how the mental efforts, meditation, whatever, can influence health, body, etc. Nobody can beat Deepak in making that connection, and I'm highly recommending these two books for that connection. Thank you.
Since we're going to hear other views and we're running kind of tight,
Yeah.
I think I'll ask Minas, do you have any comments to make? And Chris Fields, if you're there, can you come up for a second just to make any comment that you have based on this? Then we're going to have other views expressed later as well.
So, Henry, I wanted to ask your opinion or your view. You mentioned quite correctly there are unorthodox views, and you don't quite believe in those unorthodox views. One of the unorthodox views, which is very, very popular these days, for actually about 10 or 20, more than 30 years, is the many worlds interpretation. The many worlds interpretation has, in fact, some circles say that it is even more accepted by physicists than the orthodox von Neumann interpretation that you are favoring, which I'm favoring. What is behind this many worlds interpretation that makes it so strong that even people like today, after Everett passed away, they're still following that interpretation?
What makes it strong is your
Yeah,
question?
at least in the minds of some of these physicists. Why is it so?
I guess I
Yeah,
can talk from
your
here.
mic is.
Well, what makes it strong is there's no collapse. I mean, these sudden collapses are very mysterious. They're such that an observer here observes something, and if he's observing something that's been correlated by something in the past, maybe you have an explosion here and some particles go out, and there's a correlation between what's happening here and what's happening here. If you determine what's happening here, this quantum collapse has to say that, you know, if A is correlated to B here and A prime to B prime, if you find A here, you've got to find B here and not the other thing. So there's this instantaneous thing, which Einstein was very adverse to, and many other people are adverse to it. They don't. So if the question is, why is it appealing? That's why it's appealing. But the question is, they have to then determine, you say many worlds, so you have to have this one wave function, this Schrödinger evolving wave function of the universe, which is the state of the universe. How does it get divided into all of these separate parts?
Separate
And
parts.
that's the same question as I was asking before. When you're doing an observation, in order to make quantum mechanics work, you have to divide this thing which is a continuum, and which always evolves into more and more continuous stuff, into discrete questions. Like if the pointer is smeared out, according to quantum state, from 1 to 10, you've got to ask a question like, is it between 5 and 6? Yes or no. It has to be a yes or no question. You can't say, where is it?
Correct.
You've got to say, is it between yes and no, or between 5 and 6? So the question is, how do you then, in the many worlds interpretation, divide it into the different worlds? And it's essentially the same sort of question. You seem to need something outside the evolution of the world as described by the Schrödinger equation to answer these questions which require a discrete answer emerging from a continuous evolutionary equation.
Continuous and deterministic. Thank you.
Okay?
So, you know, we're going to finish this very soon, but before that, you know, we have a book that was published recently, which I edited, which had many of the physicists here.
Right.
It's called Brain, Mind, Cosmos. It has Stuart's contribution. But
Thank you for
as I
asking
was
questions.
eliciting chapters for the book, I asked everyone to sum up their entire chapter in one sentence. And so Chris Fields is also a physicist, and I said, can you sum up all of quantum mechanics in one sentence? And he said, there are no boundaries in the universe. Every boundary is notional. Would you comment on that, and then we can close the session?
Yeah, thank you, Deepak. Actually, I'll make a comment along those lines that I think is quite relevant to the question that Stanley here ended with, which is, what's the observer? And if you take the essentially arbitrary ability to cut up the state space that quantum theory gives you in any way that you want, a lovely feature of quantum theory is that even the state space of the entire universe can be divided up in absolutely arbitrary ways, and the way you divide it up makes no difference whatsoever to the physics.
Right.
If you take that idea very seriously, then every possible subsection of the entire universe is an observer.
Yeah.
And we can treat everything as an observer, and not just one at a time, but all simultaneously.
Right.
So
I like
that allows you to think of not just us as observers, tables and chairs are observers, electrons are observers, and so what is happening can be thought of completely as observation. And this is certainly not my unique position. Christopher Fuchs, who some of you may know, who basically came up with quantum Bayesianism, and I'm not a quantum Bayesian, but he does agree with me here. He characterized the universe as pure experience and everything in it as an experiencer. So I think that's a nice way to think of one of the distinctions between quantum theory and classical mechanics. Classical mechanics doesn't actually talk about experience at all. Quantum theory is consistent with regarding everything as an experiencer.
Okay,
don't know
last
if I
comment with Henry. Henry wants to make a comment.
I would say that that's right on the money. And I think what Stanley was showing with these cuts is, if you keep following that, really there's no cut anywhere. Henry, you want to say something?
Yeah, I want to say that, no, you're missing the main point. These collapses have to be associated with minds. So you have to ask, what
are the minds?
What has minds? And so the way that the original Copenhagen interpretation went is that we want this to be about science. Science is done by scientists, and we're going to mainly talk about human minds. So initially, and if you talk, I've had a number of conversations with Heisenberg, that's the orthodox view. We're talking about human beings have minds. I'm quite willing to say maybe all biological systems have minds, but it associates minds with basically something like a biological system where you have a brain and you're supposed to be associating a mind with it. So it's not that everything is allowed, but you do have to say what sort of systems have minds. Let me put forth every biological system that has something like a brain has a mind. That would give you a first approximation to an answer that would be a little bit broader than Copenhagen, but
Chris,
nicely.
we're going to continue this conversation, but I'd like to suggest, if you're on Twitter, maybe you can all express your opinion to the following question. Is the universe more mind-like or machine-like? Could you give your opinion based on what you've heard? Thank you very much.
Thank you.